All right, so this video is going to cover inverse variation for um, section 8.1 in algebra 2. Inverse variation. So first, let's remind ourselves, well, what is direct variation? Because direct variation kind of is the easier one. Well, they're both pretty similar, but let's remind ourselves what direct variation is. So direct variation is where two things are directly related by a constant k. So we typically write the formula as y equals k times x. So x and y are related by a variable k. Now you could switch the x and y. They could be different letters, but y varies directly to k is kind of how you say that, or you might see it in a problem. But k can't be 0. So basically, as one increases, the other increases by a scale factor, or that direct variation, that constant k. So if we look at inverse variation, then we can say, all right, well then y is equal to k divided by x, or the inverse is like one's getting bigger as the other gets smaller. And again, the y and x could be switched depending on how the wording is, or they could use different letters. So if we'd say y varies inversely to x on this situation here, and k again is our constant. So let's think about it. As x gets larger, we don't care what the number is up here for k. As x gets larger, that fraction's going to get bigger, right? So if I have 1/2, or excuse me, the fraction is going to make, as x gets bigger, I said the fraction gets bigger. The fraction is going to get smaller, meaning y is going to get smaller. So think about this. X gets bigger, like if I have 1/2, if I put in 4 instead of a 2, it'd be 1/4, and then 1/8, 1/12. If I think about how that x gets larger, those fractions will get smaller and smaller and smaller, so y is smaller. So as x gets bigger, y gets smaller. So they're inversely related. One is going to decrease as the other increases. That's kind of the difference between direct and inverse variation. And k is always our constant, and you have to find that k first. So let's look at some points and some examples that you're going to be doing, or problems. What if we just had these points here? Like we had, okay, 4 is to 28, 6 is to 42, 10 is to 70, and 12 is to 84. Let's look at these and let's decide, are these directly related or inversely related? And then let's write the formula for it. Okay, so find our constant and write our formula for it from points. And there's a couple ways we could do that. Okay, so look, 4 is, and then it's going up here. 4, 6, 10, 12 are bigger. But look on this side, they're going bigger as well. So both are getting bigger. That's going to mean they're directly related, right? So we're going to use this formula for that, and we could use the one set of points to find our k, and then use our k to rewrite the formula. I'm showing you this way because you could have problems that have k as a decimal and or something you can't figure out. So this is kind of the longer way, because a lot of you are saying, well, 4 times 7 is 28, 6 times 7 is 10 times 7. So we can see the constant by looking at what are you timesing x by to get y. You can see it. But again, sometimes we can't see it. So what we would do is we would know this is our general formula, and we'll just use the first point here. So we'll put in the y, which is 28. We don't know k, that's what we're looking for. And our x is 4 times 4. So we can put this in and then divide and solve for k so that we can see that k is 7. Then we rewrite the formula to know that the relationship between y and x is 7 times x will give you y. So 7 times x will give you y, or here is your general formula. So I like to write the formula and then find that k and rewrite it. Or again, look at the pattern. What are we timesing by? Okay, so the second example here, X, Y, a little bit harder. 1, 3, 2, 3 halves. And you could see these in decimal form. I left them as fractions, 3/4. It really wouldn't matter to me either way. And you might get the joy of hearing my children behind me today. Okay, so when we look at these numbers are getting bigger, but what's happening to these numbers here? We have 3, we have 1.5, 1, 3/4, 3/5. They're getting smaller. So then we know they're inversely related, but they could, I guess I didn't bring up the fact that they have to be the same factor, that k has to be the same all the way down. So we have to check that. And we check that by that the products of the two numbers have to be the same all the way down. And so we can look at 1 times 3 does give us 3. Okay, so we're going to go 1 times 3 does give us 3. 2 times 3 halves does give us 3, because the 2's cancel. It's like 2 over 1 on the first, and so we get 3. 3 times 1 we know is 3. And 4 times 3/4, the 4's cancel, we get a 3. 5 times 3/5, the 5's cancel, and we get a 3. So we can see, yes, they are inversely related. You do have to double check to make sure that they're related. You can't talk to me right now. You have to give me the minutes I asked for. Okay, so we know they're inversely related. Now we can say yes, and k is going to be 3 because they're related by 3. So we could write our formula right away. We could still do the same method up here too if we need to, using, we know, is y equals k divided by x. But we already know k has to be 3 because they're related by that 3, that factor of 3, by doing our cross product. So we can, again, we could write this out. We could put in the 1 and the 3's. So 3 would be here, 1 would be here. We could solve for k by timesing it over and seeing that k is 3. Or we could just take the 3 from the cross products and say, all right, then here's my formula. They're related by 3. All right, so here's another way that you might see it that's a little bit different. So all of them are the same, but now you're going to just see different types of problems for them. So what if I say x and y vary inversely and x equals 4 when y equals 12, write the function for the situation. Sometimes you'll see then what is y when x is something, or what is x when y is this or something. So you might not have the function, you might have another part. But what they're saying in this, and I want to make sure you understand, is x and y vary inversely. And x equals 4 when y equals 12. So we know they vary inversely. So we write, first, our first step is to come up with that general formula that we know. Well, it comes from the wording, inversely. You could see direct. Sometimes you see joint or combined. Combined means you have more than one, like you might have more than one letter being times down here, or in the direct it would be like k times x times z times t or something. So there's a combined word you might see as well. Not so much in this section for you, but you might see it on an ACT or some other place. Let's see. So we know I really should, well, okay. So we know that the general formula is y equals k divided by x. So here's our general formula. So let's put in the numbers that we know. So this is our step 1. So we know they gave us an example. So it's 12 equals k divided by 4. And then we could see that if we times the 4 over to 12, that's going to give us 48, which is our k. So this is kind of our three-step process, or one, I don't know, however you want to think of it. You've come up with your formula, you use your example. It's the same as when I had the point, x, y, I find my k, and then I rewrite my formula and I'm done. So y equals 48 divided by x. Okay, I don't think I have any other. Oh, I had one other way that we could have written these. So let's see, one other way I could have written these, so this is problem 4, is as points. 9, 11, and 18, let's say y. And your directions will tell you different things. Like this one I'll say they're directly related, find y. You could say inversely related, or however you want to say it. So they may give them in forms of points. They may write them out. So they kind of try to confuse you, but I want to make sure you realize they're all x, y, and then this one wants us to find the y. Well, I can see the relationship. 9 times what is 18? Well, 2. So 11 times 2 is 22. So I can see the relationship and come up with the answer fairly easy. But let's say it was a decimal and I didn't know. The directions said these are directly related. So our general formula is y equals k times x. And then we'd put in our numbers from the one that has both. So we would say, okay, 11 equals k times 9. Divide that over, and I'm going to get 11 ninths is k. And then I take k, so I know my formula now is 11 ninths x, right? Rewrite your formula. And then put in the number that we're looking for. Well, x is 18, so we got to put in that number. So we have our 11 ninths times 18, think of that as 18 over 1, right? 9's going to go into 18 twice. 2 times 11 is 22. So I found the same answer, y is 22, by looking at the pattern. 9 times 2 is 18, so 11 times 2 has to be 22, because we know they're directly related. Okay, works the same if it was inversely related, but that's the other little bit tricky way you might see a problem. All right, good luck on this section, and don't mind the bald head. My hair will grow back.